Hello, dear students. Now we are going to cover an important topic, that is the types of functions. So now the first type is the one-to-one or injective function. So a function from A to B is called as an injective function if for each element of A there is a distinct element that is mapped in B. That means distinct elements in the domain have distinct images in the codomain. That is a one-to-one or injective function. So here I have an example of a function f of x equal to x square. So here x will be from the first set A, that is the domain, and x square will be from the second set, that is the codomain. So here the domain is defined as the set of positive integers. So here I can take any positive integer, let's say 2, 3, 5. So here this x, it will be related to an element x square in the codomain. So 2 will be related to 4, 3 will be related to 9, 5 will be related to 25, and so on. So here in this case, you take any positive integer in A, it will be mapped to unique integer in B. Why? Because every positive integer has a unique square. So this is why this particular function is one-to-one, but only if the domain is the set of positive integers. Now, what if I take the domain as the set of integers? So here, if I take domain as the set of integers, what will happen? This will remain as it is. But what about -2, -3? -2 will also be related to 4. -3 will also be related to 9. Why? Because square of negative numbers is also positive, and the square of -2 and 2 is the same, that is 4. So here distinct elements in the domain are not having distinct images in the codomain. That is why this function is not one-to-one over the domain of integers. Okay, so this was an example of one-to-one. Now next is onto function, which is also called as surjective function. So a function f from A to B is a surjection if each element in B has at least one pre-image in A. So here there is no requirement of distinct mapping, but each element of B is mapped to at least one element of A. That means every element of codomain should be mapped. एक भी एलिमेंट छूटना नहीं चाहिए कोडोमेन में से. Okay, in short I can write what? I can write this: codomain must be equal to the range. This is the condition to check if the given function is onto. So if you see in the figure, this first figure shows a surjection. Why? Because all elements in B are mapped to at least one element in A. But in this figure, the right one, it is not a surjection. Why? Because 4 is left out. Hence, it is not a surjection. So I'll have another example of a function f of x equal to x plus 1 over the set of integers. So if I take the domain and codomain, I take 1, 5, 9, it will be mapped to its plus 1. So x will be mapped to x plus 1. 1 will be mapped to 2, 5 will be mapped to 6, 9 will be mapped to 10. So there will be no element in B that will be left out. Even if I take 0 in B, what will be its pre-image? Pre-image will be -1. So you can find you can take any damn integer in B, it will be having a pre-image in A. So that is a example of surjection. What about the next example? F of x equal to x square. Is it a onto function? We just saw it previously. Are all elements in the set B mapped to some element in A? No. Why? Because there are various examples, various integers that are not perfect squares. Let's say 2, 5, 7, -12, -13, and so on. Even -16 is not a perfect square. So there are many elements that will be left out in the set B. So that is why it is not a surjection. The non-perfect positive numbers, non-perfect square positive numbers will be left out, as well as all the negative integers will be left out. So that is why this is not an example of surjection. Now, next is the bijective function. So a function which is both one-to-one and onto, it is called as a bijection. So in other words, the function f associates each element of A with a distinct element of B, and every element of B has a pre-image in it. So that is a bijective function. So example is f of x equal to x. So that means every element in domain is mapped with itself in the codomain. So I can take it over the set of integers. So here 1, 2, -5, -8. Okay, these will be mapped to themselves. So 1 will be mapped to 1, 2 will be mapped to 2, -5 will be mapped to -5, -8 will be mapped to -8. So all the elements in A have distinct images in B, and each element in B will be mapped to some or the other element in A. So this is a perfect example of a bijection. So this was about the types of functions.